Hi, this question is about the pressure exerted by this cylinder, which is hollow from inside, and I have shown you here its 3D view. So you can easily see that this is a hollow, and I can consider this is its axis of rotation. Okay, so important thing is you see that this is its thickness, right? So which is basically the value x according to the question, and you can easily see this thickness over here, so this value is x. And one another important thing to note, in the question they have mentioned properly that the radius of the cylinder, which is its distance from the center to this that end, this radius r, is noticeably larger than the x, right? Which means that the r is much greater than x. Okay, so it means that if, let's say, if I take the square of x, right? So I can assume it is 0 because it is comparably very small. So it is placed on this flat surface, and we have to find out that what pressure does it exert on this flat surface if its weight is W, right? So W is its weight, which is passing from its center of mass, and it is exerting force on this flat surface. That is a normal force, and this force is the pull of Earth on the cylinder that we are calling the weight W. Another thing, so what surface is making contact with the flat surface? What part of the cylinder? It is very important to note what part of the cylinder is making the contact with the flat surface. So you would see that it is obviously this part. If I shade it for you so you can see that this is basically the thing that is making contact. Okay, so it is exerting force on a flat surface. So it is very important to note, to find out the area of this surface, which is not pi r square because this is hollow from inside. So how can we okay, so let's see. We want to find out the pressure, and the pressure is always equals to the force, normal force per unit area. So the force here is the weight, okay? So the W over area A. So area is basically the area of that part of the cylinder which is making contact. So why not, if you find the whole area, like I mean to say the area, the complete area of this thing, okay? So don't you think it should be pi r square, right? Pi r square. And if we find this area, the area of this hollow part, okay, but before we find the area of this hollow part, we must know that actually uh what is the radius of this hollow part. Okay, so I explain you this, that from the center of the hollow cylinder to this point, the distance should be equals to basically r minus x. The reason is that this distance is the thickness of this side, and the total distance is r. So this will give you the radius of this circular part. Okay, so this is a horizontal circle. Anyway, so if you want to find out its area, so dear students, this area should be equals to pi into r minus x whole square. So I was saying that if you want to find out the area of effective part, which is exerting pressure, so that should be equals to the total area pi r square minus this area r minus x whole square. So it is pi r square minus pi into r square plus x square minus 2r x, right? So if you open the brackets, so pi r square minus pi r square minus pi x square and plus 2 pi r x, right? Now we can cancel out this pi r square with this pi r square. And secondly, you remember that I told you the x is comparably very small, so its square is almost negligible, so we can make it almost zero, right? So I think it's not complicated thing. So what is it left behind? So effective area is just 2 pi r x. So hence, when you will find out the pressure, I told you the pressure is equals to the weight over the area that is effective. So it is 2 pi r So the right answer is option A. If you look at this question, the option A is exactly this.